Laser cooling is expected to yield 200% performance gains on the latest NVIDIA or AMD hardware with a 40 times efficiency improvement compared to liquid cooling. Can Hyperstealth's patented laser splitter further improve these results? Data centers and energy usage will account for 12% of U.S. electricity by 2028, more than a doubling of our current 2025 power demand. CPU and GPU processors have higher power densities than the core of a nuclear reactor. Photonic cooling targets these areas with lasers. In 1997, the Nobel Prize in Physics was awarded for laser cooling. In optics, an ultra-short pulse is also known as an ultra-fast event. Lasers can be pulsed in nanoseconds, which are billionths of a second, or in the ultra-fast regions in picoseconds, trillionths of a second, to femtoseconds, quadrillionths of a second. In 2023, the Nobel Prize in Physics was awarded for ultra-short laser pulses with the development of attosecond pulses. 1 attosecond is equal to 1,000 zeptoseconds, or 1/1000th of a femtosecond. These ultra-short pulses allow for frequency tuning and oscillations, which in turn can create unique resonance waves which cannot be achieved with other light sources such as LEDs. The innovative concept of resonant damping involves directing laser light at a hot spot in the material and tuning it to a specific frequency, leveraging oscillations and resonance to prompt the material to emit more photons than it absorbs. This process effectively dissipates heat as light, facilitating cooling in a highly efficient manner. In 2012, Niels Bohr Institute researchers successfully cooled gallium arsenide in a vacuum to an impressive 4 Kelvin using this method. Subsequently, in 2020, researchers demonstrated the miniaturization and integration of laser cooling systems into microchips without a vacuum, signifying a leap in technological advancement. Collaborative efforts announced in April 2025 with a Cooperative Research and Development Agreement, CRADA, between Sandia Labs, Maxwell Labs, and the University of New Mexico in the United States are at the forefront of developing a laser cooling prototype. Under the CRADA, Maxwell Labs will provide the technical designs. Sandia Labs will fabricate highly pure gallium arsenide-based devices using its expertise in molecular beam epitaxy, and UNM will evaluate the thermal performance of the resulting systems. Sandia's decades-long experience in producing high-quality semiconductors, bolstered by its role in the Center for Integrated Nanotechnologies, CNT, a DOE Office of Science user facility, ensures the precision and purity required for the photonic cooling system to succeed. This groundbreaking initiative is anticipated to not only deliver substantial performance gains and efficiency improvements on cutting-edge hardware, but also address the critical cooling challenges posed by increasingly dense chip designs and demanding performance requirements. Laser cooling technology utilizing ultrapure gallium arsenide, GaAs, cold plates has revolutionized semiconductor cooling processes. By directing precise laser beams of a specific wavelength onto these plates, the semiconductor can effectively dissipate heat at targeted locations, leveraging GaAs's high electron mobility. Despite the overall membrane temperature increasing slightly, the strategic oscillation cooling mechanism controlled by laser light enables efficient cooling within the semiconductor, showcasing a unique cooling by warming phenomenon. This innovative approach has been in development for approximately a decade, with significant milestones achieved. Hyperstealth's patented laser splitter technology could play a pivotal role in enhancing cooling efficiency for microchips. By effortlessly dividing a laser into hundreds, thousands, or millions of lasers without any moving components, this innovation has the potential to amplify the cooling effects on microchips, with each laser beam precisely controlled by the primary laser source. Note: Hyperstealth has not been in contact with Sandia Labs, Maxwell Labs, or the University of New Mexico regarding our patent. As AI power requirements expand beyond the current capabilities, where Microsoft, Alphabet, Meta, and Amazon look to reopen nuclear power plants, build new ones, or purchase power from existing nuclear power plants just to power data centers. A major hurdle of these new data centers is the heat produced from the increased processing speeds. The limiting factor in Moore's law, the observation that the number of transistors in an integrated circuit doubles about every 2 years, is no longer due to the refinement of transistors or circuits, but the heat they generate. Laser cooling should solve this problem, and Hyperstealth's laser splitter could drastically improve on their current results. Hyperstealth now has 41 patents granted with 752 claims in the field of physics, with 7 more patents approved with a further 109 claims awaiting formal granting.